Thank you for listening to this presentation on wildland-urban interface fires, where we try to look beyond the obvious problems in Southern Europe and face north to see what we can learn from the recent events the past few years in Scandinavia, exemplified by Sweden and Norway. We're going to go through two large incidents in Sweden and two incidents in Norway in 2014 and 2018. But first, I'd like to give you a little historical overview of the fire frequencies in Sweden. In pre-industrial ages, they were very high. So land burned approximately every 30 to 80 years, depending on location. Then in the mid-1800s, large-scale forestry commenced, and thereby arrangements of firefighting resources in the villages. And this reduced fire occurrence significantly. And with the onset of modern technique during the 20th century, today the fire areas are reduced by about 99% compared to before 1850s. If we look at the population density in Sweden, we see that people live in the southern third, basically, mostly around the Stockholm region or the west coast. The rest of the country is sparsely populated with the exception of the coast against the Baltic Sea. And the firefighting resources naturally follow the same pattern. So the distance between fire stations in the north is quite long. So if you look at forest fires, they follow the same pattern. They focused on high population areas. If you look at fires with at least a decent size, a hectare, they are still concentrated towards these regions. But the very large fires, the one exceeding 100 hectares, they almost exclusively occur in low population density areas. And we know that the time it takes for the firefighters to reach a fire, so the time to arrival, has a strong dependence on the final burnt area. So if you wait more than 20-25 minutes, there is a high chance that your fire will grow very large. And this is a good time to start with our first example, which is the Västmanland fire from 2014. The fire was started in the rural part of the country during a year of moderate fire danger. So there were no other major fire occurring at the same time. It was ignited by a forestry machine like the one depicted here, and the operator couldn't handle it initially, so we called the fire department. Unfortunately, the firefighters arrived over an hour after the call, and then they were met by this quite intense fires, lots of smoke, and very hard to control the flanks of the fire. And only 2 hours after the call, the fire had spread a long way from its ignition point. By the end of the day, in the evening, this is about 10:30, it reached a lake. The evenings in Sweden are very bright in the summers, so you can see the fire reaching the lake here at 10:26, and only 5 minutes later, the whole shoreline was burning in quite intense fires. And it all could have stopped there if the flanks, so this is the spread after the first day, if they were controlled properly. But unfortunately, we underestimated the threat from this fire. So the second day, we had enough resources to contain it here, but the fire spread to a much larger area. And so did it the following day. On the fourth day, the wind changed, and a massive crowning fire burnt this whole area here, encircled by the red line. A crown fire spreading at some parts even 80 meters per minute, and actually jumping a lake of the size of a kilometer, but luckily contained up here. During this day, there was a tragic death around here by a forestry worker. And here's a picture of the high intensity fire during that fourth day. We did a study on all the buildings that were within the fire area and looked at survivability based on fire intensity, tree types, building materials, and so on. We found that 71 buildings were destroyed, and most of them were in direct contact to the wildland, as here has been a building here, or this one here, which is directly adjacent to the forest. But many also survived. Most of them where the fire was maybe low intensity. You can see here a low intensity fire burnt this outbuilding here and outbuilding here, but it stopped at the garden of this house, which was perfectly safe from the fire. Another example is here, low intensity fire burning a structure here. Embers must have caught this structure on fire. But this house was protected since the fire didn't cross the highly managed lawn here. Third example here, high intensity fires. All these trees burned completely. A number of structures burned here, but when the fire reached this lawn, it stopped. And by the help of some firefighters, you can see the hose line here, this house was safe. So the take-home message from this fire is that we have a potential for very large fires in Sweden if the weather allows. But we have very poor resources to deal with these large fires and also very poor experience. A long time to initially reach the fire was the key to its fast growth, and the underestimating of the fire during the first days led to the catastrophic behavior during the fourth day. And a managed lawn around the house was the most important factor for survivability, more important than clean gutters or if any windows or doors were open or even the fire intensity around the building. Our second example occurred 4 years later during the very dry summer of 2018. This year the whole country was very dry and there were fires occurring all over. So resources were very scarce. And in July, 3 fires occurred right here in the central of Sweden. These 3 fires by lightning strikes. 2 of these were actually put down at an early stage and controlled, but not maintained properly. So the next day they reignited and were let to spread. Actually, this happened to 9 of the 12 largest fires in the country during this year. Here's a picture of one of those fires at the initial stage. And we did the same analysis for these 3 fires and found that luckily there were few houses within the fire area, and about 50% of those houses survived. An example is here where a fire spread through a conifer forest towards this house, which was actually saved by this narrow corridor of broadleaf beech trees, leaving the house and the garden safe. Also, there was a whole village here threatened by the fires, but this was protected by heavy aerial firefighting from helicopters, which actually took water from this river here, used this lawn as a helicopter landing spot, and the fire came close, but the houses were saved and are still there today. Other houses were not so lucky, of course. Most of them had a very close distance from the facade to the wildland, to the conifer forest. 2 examples here. We can also see that the vegetation type around the gardens were very important. So if they were situated within a pine forest, within 40 meters from the building, this blue curve, the damaged structures, were much larger than the occurrence of the undamaged structures. If instead we had a mixed forest of conifers and broadleaves, the rate of undamaged structures were much higher, as it was also if you had other open land such as fields or pastures around it. We also noticed that the distance from the facade to the wildland was very important. And actually 10 meters gave you some help, because above that the survivability increased significantly. So the take-home message from this year was that poor mop-up after the fire was a major factor leading to many high intensity and severe fires. And this was all due to resource scarcity throughout the country. In fact, 30% of the help came from other countries than Sweden. Many buildings that burned did so in low intensity fires because the residents has been evacuated and the firefighters were busy fighting more intense fires elsewhere. And also that just a small distance to the wildland from the facade significantly increased survivability of the structure. And these two fires that you heard now, they both occurred in rural areas, but there is a potential for the same fires to occur in much more densely populated areas. This is an aerial shot of a settlement just north of Stockholm, where you have lots of single dwellings and townhouses, most of them made of wood, directly adjacent to this conifer forest. Before we wrap this up, I'd like to go back again to the year 2014, but in January, where a number of unusual fires occurred in Norway. Norway has large coastal heather landscapes, like the one seen here. And heather is flammable even at quite high moisture contents. And traditionally, this land is managed with prescribed burning by farmers, but this tradition has decreased significantly in the last few decades. And 18th of January in Norway, there was a big fire starting in Lærdal, the central south of Norway. And the whole country was very, very dry during this year. Precipitation was a lot less than normal Januaries, where it's usually snow covered everywhere. And just about a week later, there were multiple fires also further north with this Flatanger fire as an example, which I will go through briefly. So the Lærdal fire on the 18th of January, in the middle of the night, started spreading from one house, sweeping through this village, which actually is a UNESCO heritage site due to many of its very old traditional timber buildings. And fires swept through it and burned 40 houses, many of them belonging to this heritage site. Some of them luckily survived. The conditions during this night they were awful, with very strong winds and embers flying everywhere in the pitch black night of January. And despite it only being 10 hectares in size, 40 buildings burned down. And just a little more than 1 week later, further up north in a peninsula called Flatanger, there were two uninsulated power lines that struck and ignited some grass. This fire spread also during night rapidly in the mostly heather-dominated landscape over the whole peninsula, as you can see here, towards the ocean and the shoreline, where most of the residents live. And this fire, covering 1,500 hectares, burned 63 of these buildings. Also very, very difficult to extinguish due to freezing degrees, strong winds, and very poor sight due to the Arctic winter. So the take-home message from these fires is that we can have very dry weather in places and seasons where we're not used to at all, especially close to the mountainous region in Norway. And that fire spread in heather is completely different from what we anticipate from forests. The forest fire danger rating for this day was very low, but instead we saw rapid spread in heather. Also, our buildings, which are mainly timber, they can become very dry during winter, if we have dry conditions. And with these dry buildings, also we have an increase in ignition propensity. And finally, the operation during winter is very difficult because it suffers from darkness and sub-zero temperatures. So I'd like to conclude this whole presentation with this figure where a fire stops just next to a building with a nice managed lawn. That in Scandinavia there is a very high potential for log consequence wildland urban interface fires, even though they're not so common. The Scandinavian countries are not prepared for very large WUI fires. And we learned that a managed lawn and a 10-meter distance to wildland is a very, very cheap and good insurance to save your property. And that our fire danger rating in parts of Scandinavia, at least, are definitely not well described by the normal models that used for boreal areas. Thank you for listening, and goodbye.